Okay, let's get started. Before you guys head over to Ixl, let's try some basic stuff here with exponential functions. And they're called exponential functions because the variable is an exponent. So we're talking about functions generally of this type. F of x is equal to 8 times b to the x. Now it is possible that we could have an additional plus or minus k here, and that would just shift our graph up or down, but it wouldn't change the shape, it wouldn't change the type of function, whether it's growth or decay. So a couple of things to keep in mind. First of all, this is our starting value, basically. This is the number we would begin with. It's also going to be our y-intercept if it's there. Because this right here, remember the y-intercept of a function is always the value of the function when x is 0. Anything to the 0 power is 1. So whatever this number is multiplied by 1, that will basically represent our y-intercept. Unless, of course, it's been shifted up or down, and then we just have to take that into account. So this is what we call the initial value, and just like in linear functions, you know, our y-intercept we often think of as the starting point. When x is 0, before things start changing, this is where we start. And then this part right here, let's pick a different color, is the so-called multiplier. This is, you know, this is the thing that really drives the growth over x intervals. So if x is years, this is some percentage that's been added to or subtracted from 1, and that's a growth rate or decline rate per year based on x years. It doesn't have to be x years. It could be x could be decades, x could be periods of 50 years, etc. So let's just look at that. That's the basics of the function. That's just what the functions look like. They're pretty easy to work with. The first thing we're going to do here in Ixl level M, we're going to do S.2. So this next couple of screens are just a couple of example problems for that topic. Here's one. This would be the first one you'll see. They'll give you a simple exponential function, and they'll just ask you to evaluate it for f equals 0. So that's quite easy to do. That just means finding f of 0, which is 11 times 5 to the 0 power. Well, that's 11 times 1, or just 11. Pretty easy. Same idea here. We're trying to find f of 1 for the function 6, in this case to the 1 power. Well, that just equals 6. Find f of 4 if the function is defined as 3 to the x. So f of 4 is basically like finding the value of 3 to the 4. And 3 to the 4th is 3 squared times 3 squared, which is 9 times 9, or 81. Of course, when we get into bigger numbers here, you're certainly going to want to use a calculator. I think you guys will zip through this first topic pretty quickly without too much trouble.